When you hear the name Einstein, what immediately springs to mind? Is it the wild hair, that famous picture with the tongue out, or maybe EMCR?
Yeah, those are the iconic images, aren't they? The sort of pop culture version of Einstein. But there's, well, so much more depth there.
Exactly. Most of us just picture this singular genius, but Albert Einstein was far more complex. Today, we're taking a deep dive into his whole journey.
We're going to trace his life, chronologically, from his, let's say, rebellious youth through those incredible scientific breakthroughs right up to his very passionate activism later in life.
And we'll also look at how people evaluate his legacy now, which is also pretty complex.
It really is.
So our mission today is really to give you a shortcut to being genuinely well-informed about Einstein, not just what he discovered, which is amazing in itself, but who he was as a person, a human being.
And maybe why his life, his insights, his struggles, why they still feel relevant, why they still resonate today.
Okay, let's jump in. Where do we start? His early years.
Right. Born in 1879. And he certainly wasn't your typical model student, not by a long shot.
How so?
Well, his whole academic approach was pretty unconventional. He apparently often skipped lectures he found boring, preferred to study on his own.
I read he even called professors Mister. Is that right?
Yeah, reportedly.
Yeah.
Which, back then that was quite bold, almost disrespectful, you could say. One of his professors, Herman Minkowski, even called him a lazy dog.
Wow, lazy dog. That doesn't sound like a glowing recommendation.
Not exactly. And yeah, it made things difficult after graduation. He struggled to get academic or research positions, didn't have the strong recommendations you usually need.
So what did he do if academia wasn't immediately welcoming him?
He ended up taking a, practical job at the patent office in Bern, Switzerland, handling patent applications, mostly for electrical engineering stuff.
A patent clerk. The future Einstein.
Yep. Working a pretty demanding 6-day week, apparently, and not for a lot of money either.
That's incredible. It's such a stark contrast to the image we have. But maybe working outside that rigid academic system was actually good for him. Gave his mind space to wander.
That's a really interesting thought. Perhaps that independence, that sort of distance, allowed him to think differently. It certainly suggests that breakthroughs don't always come from the expected places.
And that patent office job, that period, leads us right into something truly extraordinary, doesn't it?
It absolutely does. Because while he was doing that demanding day job, 1905 happened. It's known as his Annus Mirabilis, the miracle year.
Miracle year. Okay, what made it so miraculous?
Well, he was just 26.
Okay.
And in that single year, he published 5 absolutely groundbreaking papers in the leading physics journal, Annalen der Physik, plus his doctoral thesis.
5 papers.
5. And honestly, any one of them could probably have earned a Nobel Prize eventually. They weren't just small steps. They were fundamental shifts in understanding reality.
Okay, lay them on us. What were these foundational ideas?
All right, so first there was his work on the photoelectric effect. This proposed that light isn't just a wave, but also comes in discrete packets, or what we now call photons.
Yeah.
That was crucial for quantum mechanics.
Quantum mechanics. Okay, what else?
Then there was his paper on Brownian motion. It provided really strong evidence for the existence of atoms by explaining the random movement of particles suspended in a fluid. Basically settled a long-standing debate.
Evidence for atoms and the basis for quantum theory, all while working at the patent office. That's wild.
It is. And he wasn't done. Then came the special theory of relativity. This completely changed how we think about space and time, merging them into a single space-time continuum. Specifically in situations where gravity wasn't the main factor.
Space-time.
Okay.
And the big one. The equation everyone knows.
Exactly. That same year, he also published the paper outlining the mass-energy equivalence, E.M.C. Fanner.
The iconic one. So what does it actually mean?
Essentially, it unified the concepts of mass and energy. It showed they're intrinsically linked, different forms of the same thing, really, and it revealed the immense amount of energy locked up even in stationary objects. Just mind-blowing potential energy.
What a year. Just unbelievable output. So did the scientific world just immediately erupt? Did they recognize the genius straight away?
You'd think so, wouldn't you? But actually, no. It's fascinating. His 1905 papers initially got very little attention. They sort of flew under the radar for a bit.
Why was that? Were they too radical?
Partly that, yeah. But also, the format he used wasn't typical for academic papers at the time. And remember, he wasn't embedded in a major university research group. So it took his contemporaries a while to really grasp the implications, to process just how revolutionary these ideas were.
So it was more of a slow burn to becoming famous?
Definitely a slow burn initially. But you couldn't ignore ideas that powerful forever. The physics community gradually started to catch on.
And recognition did follow eventually. He got into academia properly.
Yes, he did. He started getting professorship offers. University of Bern in 1908 and Zurich in 1909. And in 1912, he actually returned to his alma mater, ETH Zurich, the Swiss Federal Institute of Technology. He was becoming a real figure in the physics world.
Okay, so he's established, and
Yeah.
then he tackles something even bigger, even more complex than special relativity.
Right. Then came the work on the General Theory of Relativity, which he published around 1915. And this one was significantly more complex mathematically.
More complex how? What was the core idea this time?
Well, the starting point, the conceptual leap, came from a thought experiment. Imagine you're in an elevator and the cable snaps. You'd feel weightless, right? As if gravity had just switched off.
Okay, yeah, free fall.
That led him to the equivalence principle, the idea that gravity and acceleration are fundamentally related. And the core idea of general relativity is that gravity isn't a force pulling objects together like Newton thought.
It isn't a force, then what is it?
It's a curvature, a warping of space-time itself caused by mass and energy. Think of it like placing a heavy ball on a stretched rubber sheet. It creates a dip, and smaller balls rolling nearby will curve towards it. That's kind of like gravity. Massive objects warp space-time, and other objects just follow the curves.
Wow, so planets orbiting the sun are just following the curve in space-time caused by the sun's mass.
That's the essence of it. It was a complete paradigm shift. And the math involved, things like tensor calculus, was really cutting-edge stuff. Even Einstein needed help with some of it.
That's truly mind-bending. And wasn't there a really dramatic event that proved him right and made him world famous almost overnight? Something about an eclipse.
Yes. You're thinking of the 1919 total solar eclipse. This was huge. A British astronomer, Arthur Eddington, led expeditions to observe it.
Why? What were they looking for?
They wanted to test a key prediction of general relativity,
Oh.
that gravity bends light. So the idea was to photograph the stars near the sun during the eclipse when its light wouldn't obscure them. If Einstein was right, the stars' apparent positions should shift slightly because the sun's gravity was bending their light on its way to Earth.
And did they shift?
They did. The announcement came in November 1919. It was quite dramatic, made at the Royal Society in London, right in front of a portrait of Isaac Newton. The results confirmed Einstein's predictions. Newton's theory wasn't wrong, exactly, but Einstein's was shown to be more accurate, especially in strong gravitational fields.
That must have caused a sensation.
Oh, absolutely. Especially coming right after World War I. Here you had a British expedition confirming the theory of a German-born scientist. It was seen as this great moment of scientific reconciliation. It made Einstein an instant global superstar. Headlines were screaming about a revolution in science.
It's amazing how a scientific confirmation can capture the public imagination like that. And that led to the Nobel Prize, right? Though, interestingly, not specifically for relativity.
That's correct. And it's a curious bit of Nobel history. He'd actually been nominated pretty much every year since 1910. But the committee often felt relativity was still too premature, maybe too philosophical, even controversial.
So they played it safe. What did they give him the prize for in the end?
They awarded him the 1921 Nobel Prize in Physics, though it was actually presented in 1922 specifically for his discovery of the law of the photoelectric effect.
Ah, back to one of the 1905 papers.
Exactly. It was seen as less contentious, perhaps firmly rooted in experimental data. It was a way to honor him without fully endorsing relativity yet. Although, apparently, when he gave his Nobel lecture, he talked about relativity anyway.
Huh. Always pushing the boundaries.
Yeah.
So by the 1920s, he's this global icon. But his work wasn't just physics, right? He got involved in philosophical debates and social issues, too.
Very much so. In 1922, for example, he had this famous public debate in Paris with the philosopher Henri Bergson. It wasn't just science versus philosophy. It was framed more as a clash between two different philosophies of time, or even two ways of understanding science itself. Deep stuff about reality and perception.
Sounds intense. And he also had some pretty major disagreements with Niels Bohr about quantum mechanics, didn't he? Even though he helped start that field.
Yes, this is one of the most famous debates in scientific history. Einstein, despite his own contributions like the photoelectric effect, really disliked the direction quantum mechanics was taking, specifically the Copenhagen interpretation, championed by Bohr.
What did he dislike about it?
It was the inherent uncertainty, the idea that randomness wasn't just a limit of our measurement, but a fundamental feature of reality at the quantum level. Einstein famously declared, "God does not play dice." He believed there had to be some underlying deterministic reality, hidden variables that quantum mechanics was missing.
So he thought the theory was incomplete.
Exactly. He came up with these incredibly clever thought experiments, like the slit experiment, the photon box, designed to challenge the uncertainty principle, to show you could know certain properties simultaneously with more precision than the theory allowed.
And how did Bohr respond?
Bohr, often after intense thought, legend has it her, he sometimes stayed up all night grappling with Einstein's challenges, managed to refute them. And often, quite brilliantly, he used Einstein's own theories, particularly general relativity, to show why the thought experiments wouldn't actually violate the uncertainty principle. For instance, using gravitational time dilation, the idea that gravity affects time, to counter the photon box argument.
Wow. Using Einstein's own work against his challenges.
Precisely. Apparently, Einstein was pretty much exhausted by these debates and eventually conceded that the Copenhagen interpretation was logically consistent, though he never truly liked it. He still felt it wasn't the final word.
Fascinating. Okay, shifting gears a bit towards his social conscience. He was living through incredibly turbulent times with the rise of Nazism in Germany. How did that affect him?
Deeply. Einstein was a committed pacifist and anti-fascist. He was horrified by what was happening in Germany, renounced his German citizenship, and eventually immigrated to the U.S.
And this led him to make a decision he later regretted concerning the atomic bomb.
Yes, and this is a really poignant part of his story. Despite his pacifism in 1939, he was persuaded by fellow physicists, particularly Leo Szilard, who were terrified that Nazi Germany might be developing nuclear weapons. They knew about the discovery of uranium fission.
So what did he do?
Based on these warnings, Einstein signed a letter to President Franklin D. Roosevelt, urging the U.S. government to start its own research into atomic weapons before the Nazis could succeed.
Which, of course, led to the Manhattan Project.
It did. And after the U.S. dropped atomic bombs on Hiroshima and Nagasaki in 1945, Einstein was filled with profound regret. He famously said something like, if he'd known the outcome, he would have torn up his EMC formula back in 1905.
Such a heavy burden for him to carry.
Immense. He spent much of the rest of his life advocating fiercely for nuclear disarmament and world peace. He gave that chilling warning in 1949, I know not with what weapons World War III will be fought, but World War IV will be fought with sticks and stones.
A powerful and terrifying thought. And his final act was related to this peace activism.
Yes. Just days before his death, in April 1955, he co-signed the Russell-Einstein Manifesto with the philosopher Bertrand Russell. It was a powerful plea to scientists worldwide to recognize the dangers of nuclear weapons and work together for peace. That manifesto led directly to the Pugwash conferences on science and world affairs, which still continue today.
A truly significant final statement. So, looking back at his whole life, his legacy is obviously enormous in science. How does his work still impact us today, maybe in ways we don't even realize?
Oh, it's everywhere, really.
Yeah.
Think about lasers used in everything from barcode scanners to surgery to Blu-ray players. The theoretical basis for lasers comes from Einstein's concept of stimulated emission.
Okay, lasers. What else?
Your GPS. The satellites orbiting Earth experience time slightly differently than we do down here because of effects predicted by both special and general relativity. Time moves faster for them due to weaker gravity and their high speed. GPS systems have to constantly correct for these relativistic effects. Without those corrections, your map directions would drift off by miles every single day.
No way. So Einstein is literally helping me find my way around town.
In a very real sense, yes. And in cosmology, his ideas are fundamental. His field equations from general relativity predicted things like black holes, and they formed the basis for theoretical concepts like wormholes, those hypothetical tunnels through space-time.
The stuff of science fiction.
Based on his math. And remember the expanding universe. Initially, he actually added a factor, the cosmological constant, to his equations to prevent the universe from expanding or contracting because he believed it was static. He later called that his biggest blunder. But then, when Edwin Hubble observed that galaxies are moving away from us, showing the universe is expanding, his original equations actually fit the data beautifully.
So even his blunder turned out to be important later on.
Kind of, yeah. The cosmological constant is actually back in vogue now to help explain the accelerating expansion of the universe, and then there are gravitational waves.
Ah, yes, the ripples in space-time. He predicted those way back.
Predicted them in 1915 as a consequence of general relativity. But they're incredibly faint. It took a century of theoretical work and amazing technological advances like the LIGO detectors to finally directly detect them in 2016. A huge confirmation of his theory.
Just incredible. Beyond the science, though, his role as a social activist, that sense of responsibility, that's also a key part of his legacy, isn't it?
Absolutely. He strongly believed that scientists couldn't just hide in their labs. They had a moral responsibility for how their discoveries were used. This is quite different from the traditional view of keeping science separate from politics.
And he spoke out on other issues, too.
Oh, yes. He was a vocal opponent of McCarthyism in the U.S. during the Cold War. And maybe surprisingly to some, he was quite critical of capitalism. He wrote about what he saw as its unethical nature and the exaggerated competitive attitude it fostered, especially in education. He actually advocated for a socialist economy focused on social goals.
He really wasn't afraid to voice strong opinions. Now, let's talk about the man himself. There are lots of stories about his eccentricities, right? And some common myths.
Oh, definitely. The quirks are fun, like the story about him hiding his hat under his coat in the rain because he supposedly said it was easier to wash his hair than clean his hat. Simple logic, maybe.
Huh, practical, I guess.
And he apparently couldn't remember his own phone number. Had to look it up. There's another story about him proudly telling a neighbor he'd made a muffler out of a tablecloth. He also loved reading Don Quixote, and the Bible were reportedly favorites, and he admired Goethe.
Okay, what about the big myth? Was he actually bad at math? You hear that all the time.
Right, that one needs debunking. No, he was not bad at math. He was highly proficient, passed advanced exams. He did sometimes collaborate with mathematicians, especially when dealing with the really cutting-edge math needed for general relativity, like non-Euclidean geometry and tensor calculus, which were quite new fields then.
So he wasn't bad at it, he just needed experts for the super specialized stuff.
Exactly. It shows he understood enough to know what math he needed and could work with the experts. He even contributed a useful mathematical tool called Einstein notation to simplify complex equations.
Good to clear that up. What about his first wife, Mileva Maric? There are claims she co-authored some of his major papers. Is there evidence for that?
That's a complex and sensitive topic. There's evidence they had an intellectual partnership, especially in his student years. He even used phrases like "our work" in letters back then regarding some early ideas. However, the scholarly consensus is that there's no solid evidence she was a co-author of the major 1905 papers or general relativity. It's also worth noting she struggled academically herself, failing her final university exams twice, partly due to math scores.
Okay. And finally, there are some more difficult, controversial aspects of his legacy that have come to light more recently, right? Things that clash with his humanitarian image.
Yes, and it's important we acknowledge this too for a full picture. His private travel diaries from a trip to Asia and the Middle East in 1922-1923 were published relatively recently, and they contain some undeniably racist and prejudiced remarks,
Really? About whom?
particularly about Chinese people, whom he described in quite negative terms, things like industrious but dirty and obtuse. He also made disparaging comments about Sri Lankans and Egyptians.
Wow. That's really jarring compared to his public image as a champion of human rights and opponent of racism.
It is jarring. And while some might try to contextualize it by saying such views were more common in that era, the universal racial views argument, it doesn't excuse them. It shows a stark contrast between his public advocacy and some of his private thoughts, revealing a much more complex and frankly flawed individual.
That's tough to reconcile. How should we think about that? Does it diminish his scientific achievements or his later activism?
That's the difficult question, isn't it? I think it reminds us that historical figures, even geniuses who changed the world, were products of their time and had their own biases and contradictions. We can admire their incredible contributions while still acknowledging and critically examining their flaws. History and people are rarely simple or purely heroic.
A really important point. So, wrapping this all up, Albert Einstein, clearly so much more than just the Eames-on guy.
Absolutely. A revolutionary scientist who fundamentally reshaped our understanding of the universe, yes, but also a complex human being who deeply grappled with the ethics of science, who evolved into a passionate advocate for peace and social justice, and who, like all of us, had his own internal contradictions.
His journey from that defiant student to the patent clerk having a miracle year to global icon to anti-nuclear activist, it really covers so much ground.
It really does. It spanned physics, philosophy, politics, ethics, the whole human experience almost.
So maybe a final thought for our listeners to ponder. Given Einstein's incredible journey, constantly balancing that intense scientific drive with a growing sense of personal and social responsibility, what does his life teach us about how we navigate those things today?
That's a great question. In our world, with science and technology advancing so rapidly, how do we balance progress with ethics? How do we as individuals and societies manage the interplay between discovery, responsibility, and our impact on the world? Einstein's life certainly gives us a lot to think about there.
It really does. Thank you so much for this incredibly deep dive into Einstein's universe and his humanity.
My pleasure. It's a endlessly fascinating story.